and separate it with addition. However, the same thing does not apply for products or multiplication. So we are going to learn the product rule and the quotient rule today. So the product rule says d dx f of x times, this is times g of x, is f of x times g prime x plus f prime x times g of x. Here's what I have you guys repeat after me. First d second plus second d first. First d second plus second d first. That's in your head. I mean, I even say it in my head when I'm doing product rule. First d second plus second d first. The first thing times the derivative of the second plus the second thing times the derivative of the first. And when I'm referring to things, I'm referring to those functions. Okay, so f prime of x, I'm going to write the long way. Alright, so the derivative of this would be, and I have two things here. So first I'm going to take x times the derivative, this is the first, right? The first function is x. What's the derivative of cosine? Who memorized it already?
Negative sign.
Negative sign. Okay, so that's first d second plus second d first. So the second thing I leave alone, the cosine of x, times the derivative of the first function. What's the derivative of x? 1. And then if possible, simplify. Well, a positive times a negative just means this is going to be negative x times sine of x plus cosine of x. Alrighty. You guys ready? Okay. So let's try this one. And we might have some simplifying to do. Okay. So on this one, the first function is x squared plus 1 and the second function is x cubed plus 3. So here we go. dy dx is first d second, so I'm going to take x squared plus 1 times, in parentheses, what's the derivative of x cubed plus 3? 3x squared. Plus second d first. So now I take x cubed plus 3, and what's the derivative of the first thing? Okay. Alright, now we're going to do some simplification. So I'm going to distribute 3x squared to the first parentheses, that's 3x to the fourth, plus 3x squared, plus it looks like 2x to the fourth, plus 6x. That gives us 5x to the fourth, plus 3x squared, plus 6x. And before we start on our homework, this applies if you're given a table of values and I don't give you the functions. You got to remember, if I said, hey, multiply, what's the derivative of this times this? Well, I'll show you in a minute. You'll know what I'm talking about. That you can't forget the product rule. Anytime you're doing a derivative and there's a product. Okay.
When you say d second, you mean like
Derivative of the second. Yeah. So, here's the deal with quotient rule. First of all, sometimes things that are divided you can simplify and use the power rule, and that is way, 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 way easier. If you can avoid quotient rule, I would, just because there's a lot involved in there, and there's a lot of simplifying, and the more simplifying, the more room for error, okay? But the quotient rule is if you have a function divided by another function, here's how it works. You start low. Low d high minus high d low, square the bottom, and away we go. I didn't make that up. That's really low. You start with low. Low d high minus high d low, square the bottom, and away we go. So what that works is the low function times the derivative of the function high, the numerator, minus high d low, so the thing on the top, derivative of the bottom. High is the numerator, low is the bottom, square the bottom, and away we go. And of course we would assume that this is if g of x is not equal to 0. Okay, for instance, in this one, I cannot simplify this. I am going to have to use quotient rule. I'll show you in the second example that you can simplify and you don't have to use quotient rule. So here we go. To find f prime of x, we're going to start low. Low d high. So we're going to write the low function times the derivative of the high function. What's the derivative of 3x minus 2? 3. Minus, so low d high, and then we flip it around, minus high d low. So now I take the high, 3x minus 2, times the derivative of what's on the bottom, which is 2. Square the bottom, and away we go. Alright, so let's do some simplifying here. We have 6x minus 9 minus, I'm going to put the whole thing in parentheses, 6x minus 4, because I'm subtracting that whole thing, right? Hey, what the heck? Let's simplify this. 2x minus 3 squared is 2x minus 3 times 2x minus 3, right? Let's see, that would be 4x squared minus 6x minus 6x. Minus 12x plus 9. Alright, if I distributed the subtraction sign, the 6x's minus 6x would cancel. Negative 9 plus 4 would leave me with a negative 5 on top over 4x squared minus 12x plus 9 on the bottom. Mr. Stalin. That's Mr. Stalin, I think. I don't know. I remember every year because he does the same thing. He gets yells really loud. You don't?
No.
Oh.
Is that it?
Yeah. So are we doing okay so far?
Yeah. But is that what the derivative is?
That's how you take the derivative of a quotient. Yeah. You can't just you're not going to just do the derivative of the top divided by the derivative of the bottom. So products and quotients you have to use those rules for. Now let's look at this. Instead of doing low d high minus high d low, let's simplify this. Can't I divide x squared by x? Can't we say this is 3 halves x? So then let's, Now, if you use quotient rule, in about 5 minutes, you'd get the same thing that we're going to get right now, but do you see what I'm saying? If possible, let's simplify. Now we know the derivative of this is just 3 halves.
Is there any way that maybe should say, but can you give this example of how to rearrange those the right way? Because I never know.
Well, I just mean if you could have something that is x on top and x on bottom, rewrite it as 1 power. For instance, it could work the other way too. Like if I had 7x over 3x to the 4th, one factor would, right? I could divide here. Okay. So this would be 7/3. The x cubed's on the bottom. We learned on Friday, how would we write x cubed? 7/3 x to the negative third, right? And then couldn't we do the derivative of that? So then we would do negative 3 times 7/3 x to the negative fourth, and go from there. Okay, so I think that actually I don't need to talk so much about this because it was something that we already did on the assignment. We already did horizontal tangents. And also, as we discovered that there are such things as second derivatives and third derivatives and fourth derivatives, and some derivatives never end. For instance, sine function. Take the derivative of sine, it goes to what? Cosine. Then take the derivative of cosine, then it goes to negative sine. What's the derivative of negative sine? Negative. Do you see how that's never going to end? Okay. However, power functions, you guys found eventually you would get a derivative of 0, right? Okay. Derivative of a constant. Here are some other ways of writing a second derivative. So just, these are important to recognize, okay? The 2 apostrophes, or this is like dy dx, and then you take the derivative again. D dx of dy dx. I would say this probably is the most frequent one that you would see. Yeah. Other ways is like this: f prime of x, f double prime of x, f triple prime. After that, we don't keep writing primes. We write things like this: the fourth derivative of x after 3 little tick marks. Okay. Okay, so let's find the first 4 derivatives. All right, so here we go. What would the first derivative of x cubed minus 5x squared plus 2 be?
3x squared minus 10x.
Good. Then we could find the second derivative. That's just the derivative of the derivative. 6x minus 10, right? And then the third derivative is the last one we can find. That's non-zero, right? And the third derivative is just 6. So then that's where we would end. Well, it technically said find the first 4, but the fourth one would just be what? 0. Okay. Alrighty. So, one more example, then I will let you do some practice. This is a really, really good sample, free response-ish kind of thing. So, remember how we don't lose sight of the fact that the derivative is the slope of the tangent line, and it's also the instantaneous rate of change. Okay? So, let's read example 7. An orange farmer currently has 200 trees, yielding an average of 15 bushels of oranges per tree. She is expanding her farm at a rate of 15 trees per year, while improved husbandry is improving her average annual yield by 1.2 bushels per year. What is the current instantaneous rate of increase of her total annual production of oranges? Yes. Okay, so this is an example where I'm going to talk to you about how we aren't going to have functions here, but we still have to remember product rule. So in general, how would I figure out in general the annual yield? What would I have to multiply together?
Just the yield?
Yeah. Or I guess what 2 things would give you the total yield of the farm? Good. Okay. So let's write an equation that, or not equation, words. We're going to say T of x is the number of trees. X years from now. Are you guys good with that?
Yeah.
And then I'm going to write y of x is the, do you guys know what I mean by yield? Yield is how much fruit the tree will produce, okay? So I'm going to say y of x is going to be the yield per tree. X years from now. Okay. I don't know. So if I wanted to figure out how many what the production of oranges was, would you agree you'd have to multiply those things together? So I'm going to write this equation, and then I'm hoping you're going to see how it's related to what we just did. P of x equals T of x times y of x. That's the production of oranges. What am I asking you to find in this problem? Yeah, the current rate of increase, right? Currently, I'm going to say that's right now. I'm asking you to find this, aren't I? Right now, 0 years from now, the rate of change of the production. Okay, so in order to do this, I have to, let's write a new function for the instantaneous rate of the production. We don't have equations, but we're going to be able to plug values in, okay? So this is product rule, so I'm going to do first D second. So I'm going to do T of x times y prime of x plus what?
Y of x.
Second T first, y of x times T prime of x. And we're doing this for 0. Now we have to figure out what is what. Okay? My general equation. So, can you guys tell me, first of all, what is T of 0 would be the number of trees now, right now? T prime of 0 would be the rate at which the trees is increasing right now.
No, 15.
How fast are the number of trees increasing right now? She is expanding her farm at a rate of 15 trees per year. Okay. All right, we would also need to know y of 0. What's the yield per tree right now? 15 bushels of orange per tree, right? 15 bushels per tree, okay. And what is the rate of change of the yield right now? Okay, and so here's what this means. Right now, each tree is producing 15 bushels. But the yield is going to increase 1.2 more bushels per tree per year. Does that make sense? So the yield is increasing. So let's plug these things in then. We're going to do P prime of 0 equals. All right, guys, what's T of 0? What am I going to put first? 200 times y prime of 0. That's times 1.2 plus y of 0, which is 15, times t prime of 0, which is 15. Yep, go ahead and get your calculators out. And what do we get? All right, now let's put some labels on this. Remember, we were trying to find the rate of increase of her production of oranges. 465 what? Oranges? Is that how they were measured?
Bushel.
Yes, 465 bushels per year.